So we'll be attending brief poster presentations on the topic of the P2.2, which is seismoacoustics sources in theory and practice, followed by the P3.1, seismic hydroacoustic and infrasound technologies and applications. The first one will be about 19 posters. I would like you to be brief and concise in your presentation, and followed by the P3.1 with 25 posters. So without any ado, I would like to invite the pastors, presenters to come here to introduce yourself and then to introduce your work. Thank you.
Good morning, everyone. My name is Ben Fernando. I'm a postdoc at Johns Hopkins University in the US. My poster, which I hope you'll all come and see in about an hour, is on seismoacoustic tracking and characterization of re-entering space debris. So we on the ground face a growing threat from items of space debris that undergo uncontrolled re-entries. We're now at a point where several satellites per day fall back into the Earth's atmosphere, and no one really knows where they're going to end up. Many of them contain materials that are flammable, toxic, or even radioactive. And in my poster, I'm going to be showing how we can use seismic and infrasound data to track and understand how these objects re-enter the atmosphere, how they break up and disintegrate, and where we might eventually be able to find these fragments. Thank you.
Hello, everyone. My name is Alim Bahadir. I am present in the Republic of Uzbekistan. I work at the Institute of Seismology. This poster represents a detection acoustic signal on seismograph following a man-made explosion. I will explain. This is important. Identify acoustic phase, help distinguish explosion from natural earthquakes, and improves the reliability of monitoring system. I analyzed seismogram for several broadband stations after industrial explosion. Delay low frequency signal matching acoustic waves. We observed this velocity between 0.27 and 0.41 kilometer per second. I also examined low frequency, low temperature, velocity, and performed spectral analysis. The most important result of our work is acoustic waves we consistently observe and can surface clear indicator anthropogenic origin, supported by velocity distance regression and frequency peak around 15 Hz. If in more detail, please visit our poster. Thank you for your attention. And against me, this poster is about seismic analysis of powerful chemical explosion that occurred in Tashkent on September 2023. I'm going to tell you why seismic monitoring and man-made hazard in urban areas are both important for fascinating. We analyzed waveform for 9 regional stations, estimated the magnitude, calculate energy release in TNT equivalent, and assessment parameters VPVS, PS amplitude ratio. The most important result of our work explosion clearly show the seismic signature of shallow, not tectonic blast, and distinguishable from natural earthquakes. For more detail, please visit our poster. Thank you for your attention.
Good morning. My presentation is about analysis of the high-frequency signals observed with Romanian infrasound arrays. And because we observed a lot of signals since military activity started in Ukraine in 2022. we observed that the signal could be correlated with the events located in LEB. So my presentation, it's an analysis of how you can associate automatically these detections. So come to my poster. Thank you.
Good morning, everybody. I'm Giacomo Belli from the University of Florence, and today I'll present you this study, which is on the use of infrasonic and seismic signals for the characterization of an unknown event in Tuscany. So last June, no, the year before, there was this powerful sonic boom in Tuscany that was heard all around the coastal area. And the event was not associated to any observed phenomenon, and so its nature remained initially unclear. So the event generated infrasonic and seismic signals that were recorded by 2 infrasonic arrays and 15 seismic stations in Tuscany. And so we analyzed these signals to characterize the source. And in particular, we performed 2 different localizations, highlighting source position in the atmosphere above the Tyrrhenian Sea. So if you are interested in more details, please come to my poster. Ciao.
Good morning, everyone. My name is Louis Chardon. I work at the Geological Survey of Israel as the manager of seismological data and products. One of my tasks at the survey is to monitor the outputs from the earthquake early warning system that has been operational in Israel since 2022. And last October, on the 26th, the first ever public alert was sent to about 1 million people in northern Israel. And it was actually due to a 370-ton explosion that the army detonated in southern Lebanon. And it was detected by Ch4 as a 5.2 earthquake, 22 kilometers west of the actual explosion. And the magnitude of estimation was a combination of this mislocation and very high ground accelerations under the stations. And if you want more details on the analysis, come see the poster. Thank you.
So, thank you, everyone. My name is Idi Alpha Jibrila from Niger NDC. So the focus of my topic is how teleseismic data help to make a good delineation from man-made event like an explosion and a natural event like an earthquake. So we have our station, which is an array station. Is a quietest station to have in the network, the PS26 TORT. So from this station, the data is collected, and as is an array, we can make a beam forming from FK analysis, and this to have a good separation of phases as the wave is coming from teleseismic 1,000 kilometers from the epicenter. So the noise are very, very eliminated, and the focus of the presentation is to show the benefits to use this teleseismic data from this station. So thank you. For more detail, please come to our poster to have more and deeply detail related to that. Thank you.
Good morning, everybody. My name is Jelle Assink, and I'm from the Netherlands National Data Center. In the Netherlands is a country that is where we monitor both induced and naturally occurring earthquakes, induced events, explosions. And we use the operational SeisComp suite for the processing of that data. And we found there was a need to add an acoustic pipeline for that as well. And so we have been working on developing that using the modules that are available as additions to SeisComp. So in my poster presentation, I would like to take you through the process of setting up this pipeline and also how we process this, the data that we are now systematically processing and allowing us to build a statistic. And of course, also the benefits of sharing data internationally, which I'm a great proponent for. So if you would like to have more information, please come to my poster. Thank you.
Hi, I'm Celso Alvisuri. I'm from Norsar. So I will talk about three things in my poster. Three main things is what is the probability that given a seismic event is of a particular type anywhere on Earth, for instance, an explosion, an earthquake, a collapse, a CLVD, and so on. Another question that I will address is how to quantify our degrees of belief given the seismic evidence and uncertainty. And the third point is I describe an approach that uses a set of Gaussian mixture models over the space of source types. And this is based on empirical evidence. And the source types are these funny diagrams that you see on the bottom left. So for any questions, please come by my poster. Thank you.
Good morning, everybody. My name is Ingo Grillmeyer. I will present you some results from a much better assessment of earthquake locations in the oceans. I'm using hydroacoustic data. And by kind of comparing the hydroacoustic epicenters we have with the kind of global detections in global catalogs, we see that the hydroacoustically derived ones have a much better kind of correlation with the geological features we are seeing. So, and on the poster, I'm also kind of discussing a couple of features which may affect the coupling of the acoustic energy into the SOFA channel where the hydrophone sits to be recorded. So it's a kind of mix of kind of better understanding of earthquakes in the oceans and understanding hydroacoustic waves and their propagation. So for more, please come to the poster. Thanks.
Hello, my name is Raluca Dinescu. I am from the National Institute of for Earth Physics from Romania, the NDC department. My study focused on the discrimination between the earthquakes and nuclear tests in the DPRK. I started with seismic data and catalog data, waveform and catalog data. I cleaned and filtered the data. I extracted the P and S amplitudes. As explosion release more P wave energy than earthquakes, so PS ratios for these ones are bigger. As another step, I compared magnitude for the body wave and surface wave. Explosions don't generate strong surface waves, so they fall below the earthquake trend. I combined these two methods, and the key result, these methods are complementary, so they are a better way to separate between explosion and earthquakes. And using this information about waveforms, ratios, magnitudes, we can give better answers in seismic monitoring and also to support the tricky verification efforts. For more information, please come to my poster. It's booth 16. Thank you.
Good morning, everyone. My name is Atala Yele from Addis Ababa University, Ethiopia. We had a very intensive colossal seismic activity starting from September 2024 till March 2025 last year. And we have used one of the facilities, that is auxiliary station A030 Fury station, and other very limited number of stations in the region. So we try to characterize this event and contribute to the disaster risk management in the country. So the other one is also if we get some logistic support and technical training like RSCTT. So we will try to characterize more events in the future. And if you want to have more discussion and maybe provide me information as well, please come to my poster. Thank you.
Good morning. My name is Islam Hamama. I am from Egyptian National Data Center. Our e-poster is about mysterious seismoacoustics, which were reported from our Egyptian seismic network, as well as some shaking of window reported near Helwan city. We deployed the low-cost infrasound station beside with seismometer and beside with a reference of MB3D sensor, and we applied some techniques like to get the impulsive signal and array analysis, and as well as we saw the detectability around the site, the expected site for infrasound propagation. And finally, these events were from deployment or construction of the corridor of high-speed railway. To know more about how infrasound can be used as a remote sensing tool, please come to visit our poster, and you can read the full paper using the QR code. Thank you.
Good morning. My name is Marino Proti. I work for the Costa Rican Volcanological and Seismological Observatory. And if you come to my poster, I will show you the first results from a very dense array that we installed near one of the cities in Costa Rica. It's 70 3-channel stations, one station every 2 kilometers. And we have been recording very local seismicity, and in the first 3 months of the array, we ran it for 10 months, and in the first 2.5 months, we recorded around 450 earthquakes, plus teleseismic events of magnitude 6 or around that can illuminate that we could use this array, stacking the signals from this short period array, we can potentially see nuclear explosions. Thank you.
Hello, my name is John Merchant from Sandia National Laboratories, and we've been looking into issues for preparing for station recapitalization to replace the digitizer, and in testing found that inaccuracies in the seismometer response model, coupled with changes in seismometer performance to the digitizer, are impactful enough that the electrical calibrations are no longer meeting IMS requirements, and that there's a necessary reconsideration of the seismometer nominal response in order to take account for these. So please, if you'd like to hear more about this, come by my poster number 23, and I'd be happy to talk with you. And I also have the next one, still John Merchant, but this is the work of my colleague, Doug Bloomquist, who could not be here. We've also been investigating the effects of temperature on seismometer performance. So we have a year-long study in which we placed thermal probes on seismometers, continually measured their variability in electrical calibration and frequency response, and correlated those changes to show that seismometers have measurable temperature effects that can also push their performance outside of the operational requirements. So again, if you'd like to hear more about this poster is number 24, right next to number 23, so I will be there for both. Thank you.
Hello everybody, and I'm Matsumoto Hiroyuki from Jamstec. And we Jamstec installed the long-term borehole monitoring system and connected to the DoNet Ch4 observatory network in 2024. The long-term borehole monitoring system is monitoring the pore fluid pressure over time, and the sensor drift is a key issue to evaluate the precise pore fluid pressure monitoring. So, prior to the installation, we pressurized the all pressure gauges to characterize each sensor. And after installation, we evaluate the in situ sensor drift. And in the presentation, we compare the results between lab tests, and in situ observations. If you are interested in my topic, please come to my poster. Thank you very much.
Hello, everyone. My name is Stephanie Donner from BGR Hanover in Germany. My post is about OSI, weather rotations. On the one side, we have OSI activities, which is a huge effort under time pressure. And on the other side, we have seismology, which so far only used the 3 components of translational ground motions. However, this is only half the information about the seismic wave field. The other half are rotational ground motions. Meanwhile, we are able to measure both of them. And the good news is, if we have the 6-component recording of a single location, we are able to derive comparable, if not better, results for scientific applications, seismological applications, where we usually need an entire array of translational stations. And if you are curious about the details and how, then I invite you to my poster 353. Thank you very much.
Hello, I'm Alan Baird from NORSAR. Our poster is about developing DAS-specific array processing for explosion monitoring. We use data from the purpose-built Norfox fiber array in southern Norway, which is co-located with NORAS, the seismometer array, which allows us to compare with more established technologies. We show beamforming for PS and acoustic waves from construction blasts, incorporating weighting to account for DAS directivity effects. And we also show examples of more complex signals, like thunder, which has many multiple overlapping arrivals that we're able to pull out of the data. So if you'd like more information, please see my poster. Thank you.
Hello everyone, my name is Kilian Venovic, working for Enviros company. Yesterday, the PTS and FISIS, the hard work that has been done to build a consistent sustainment plan. One equipment concerned by this sustainment plan is the wind noise reduction system. It's a key part of infrasound station because it's aimed for reducing the ambient noise and improves the signal-to-noise ratio in order to detect events and aim for better data quality. However, this item is one of the most exposed equipment within the infrasound array element, and when it becomes a challenge when you think about like the harsh environment you can find over the IMS network worldwide. So a lot of work has been done in order to improve manufacturing process, equipment, also to capitalize on lessons learned over installation in order to refine them, and to standardize a wide range of products in order to address all the challenges of the IMS network. So if you got some question about this topic or just related to wind noise reduction system, we'll be happy to address them during the next e-poster session. Thanks a lot.
Hello everyone, my name is Christian Espin. I am from the Geophysical Institute of Ecuador, and this poster is about a low-cost digitizer prototype based on FPGA and Raspberry. I'm going to tell you how this prototype can support the monitoring activities on low budget scenarios. I will also tell you about how this prototype was built, the basics of the design, and how the samples are acquired through this prototype. The result of this project is a working digitizer prototype based on FPGA and Raspberry Pi that can generate MSID files, and those MSID files can be transmitted through Ethernet, through SID-link to your server. If you want to find out more about this, well, you can visit my poster, and thank you very much.
Hello everyone, I'm Marian Yusko from Nanometrics, and my poster, our poster deals with the field calibration of seismic instruments. While obtaining initial calibration in lab environment is a fairly straightforward process, it becomes more involved when we try to, validate the seismometer performance in the field. And one could argue that obtaining a field calibration, conducting field calibration using a reference sensor is viable at surface installations. It becomes more difficult when the operational sensor is downhole in a different environment, different depth. So here we essentially present another convention where we achieve very high coherence from a hybrid downhole instrument with a 3-component broadband sensor with collocated force balance accelerometer. And then the second aspect of the poster deals with the temperature dependence on the sensitivity and how one can quantify and correct for this using the metadata. So yeah, if this is of interest to you, I'd look forward to talking to you at display board 32. Thank you.
Hello, I'm Nicolas Wallenstein, and we are the Sandro and the Linda. We are from the station IS-42 in the Azores. We came from the Azores Island in the middle of the Atlantic, 9 islands, volcanic islands, and belong to Research Institute of Volcanology. So, the EPI story started with the IS-42 installation certification in 2010, and since then we mainly follow the volcanic events, far-field volcanic events in Italy, in Iceland, and later with the ongoing volcanic unrest in one of the islands, in collaboration with our friends from University of Florence, we installed a portable array in one of the islands. The presence of 2 arrays in the Azores was a fantastic story because it allowed us to start to detect and to locate better local events like bolides or seismoacoustic events, and then allow us to start the projects to increase the network. So we're going to present the increase our network that we design, construct the arrays, and we're going to be in the poster to discuss the difficulties, what are the achievements, basically, when you want to work on infrasound with low budgets. Thank you very much. I'll welcome you to my board. Okay, thank you.
Good morning. I'm Jean-Baptiste Leblanc from CTBTO. I'm working on station engineering for infrasound and seismic. So in this poster we present something quite important for us, because it's in the treaty requirements, the calibration. So the past year we installed a lot of calibration capabilities for infrasound station, and we can now see that there are really interesting use case we can show and how it can help to improve the sensor design and also to troubleshoot the station. So in this presentation we also show the tool to do that, CalixPy, that has been developed by the CTBTO. And so yeah, the conclusion is that calibration is not only a requirement, but it's something very useful that could be exciting. So please come to the poster. And yeah.
Hello. Okay, looks like I don't have my slide. My name is Benoît Dourier. I'm with CTBTO as well. My poster speaks of calibration and quality assurance, which are a major theme at the SNT 2025. You can see it through the dedicated side event, which happened yesterday, and many oral talks and posters, especially under topic 3.1, which we are talking about now. In the poster, we show how the PTS is engaging with parent network operators, expert laboratories, with the metrology community and equipment manufacturers to advance its quality assurance objectives for seismic and infrasound monitoring. We highlight both achievements and challenges for both technologies with examples from laboratory and on-site calibration. Finally, we provide a short summary of the key presentations and posters on calibration and quality assurance that you can find across the conference. So if you want to see the CTBTO's perspective and a synthesis of what has been presented here on calibration, you can come to visit booth 36. Thank you.
Hello, my name is Khalil Daifallah from Research Center in Astronomy and Astrophysics and Geophysics in Algeria. So this poster, we want to present our projects to install a network, a local network of infrasound device. So the first step, we want to install 4 infrasound devices in the north of Algeria. Since 2020, we are working with 2 infrasound devices, and we are able to detect several infrasound phenomena, local or worldwide phenomena, like fireball, like hurricane and volcano, etc. And now we want to extend our network to cover all Algeria. Algeria is a very vast country, and if you are interested to this topic, please come to my poster. Thank you.
Okay, I'm Jeffrey Bainbridge from Nanometrics. We wrote this poster to support the recent CTBTO initiatives for metrology and quality assurance of seismic instrumentation. It describes Nanometrics processes for calibration and quality control of instruments in our manufacturing, and in particular, how calibrations at the subcomponent level translate into calibration of the complete instrument. Thank you.
Hello, I'm David Harris with Hyperion Technology Group. We manufacture infrasound sensors, some of which are used in the IMS stations. And my poster today covers a need that that's been expressed for the ability to have self-calibrating, self-validating sensors, and we've made a lot of headway on that. We've now developed a sensor in conjunction with the National Center for Physical Acoustics at the University of Mississippi that has a valid self-validation methodology. And I'd love to talk to you about it. Please come see my poster, and we'll show you what we can do. Thanks.
Hello, I'm Erling Sanderman Olsen from Hotting and Bryland Care, and actually the Danish primary laboratory for acoustics situated at that company. And what we have done is we have established a calibration service from 10 millihertz to 250 hertz for type 4193 microphones that are easy to use as transfer standards. What I'm going to tell about, or what I show at the poster, is that it's based on the infra AUV that you have probably heard about at sessions in this conference, and a lot of work before and after that. What we have done is actually extending a service we have had for many years, and we have determined the pressure coefficient and the full frequency range for the microphone so that it's possible to correct change the calibration values to the altitude where you are using it. And that's very important that you have that correction for the... there were a few challenges during the development that I talk a little about at the poster. So if you're interested in hearing about the service or the interesting things we made on the way, please come at position 43 and see my poster. Thanks.
Good afternoon, everyone. My name is Daniil. I am from T8 company, Russia. It's an honor to present you a survey about the ice monitoring using a fiber optic distributed acoustic sensor. In our research, we froze fiber coils inside ice surface and tried to evaluate ice thickness, analyzing seismic wave using DAS. A hammer was used as a seismic source. We compared our results with a Ch4 array. The results were agreed upon each other, and our work shows possibility of using DAS technology for long-term and long-range seismic monitoring in ice media. Thank you for attention, and if you have any questions, please come to my poster.
Good morning, everyone. I will be presenting data from a deep borehole sensor installed in Scotland of an extremely broadband instrument with a low noise performance. The information that I'll be presenting relates to signal-to-noise ratio of the instrument in relation to the EKA array, which exists 400 meters away from the borehole sensor that were installed. So the poster session that I have deals with in detail with the performance of the instrument, its frequency response, and the ability of the sensor to withstand 200 meters of depth continuously. Thank you very much.
Hello everyone, my name is Ana Maria, I am from Croatia. I am currently working in Croatian seismological survey. Our poster is about the controlled detonation of a World War II area bomb near Rijeka and how we analyze it using seismic data. I'm going to tell you why studying this explosion is fascinating. Well, because it provides a rare dataset for understanding the seismic signature of underwater blasts. What we did was process waveforms from Croatian and Slovenian seismological network and apply spectral and spectrogram analysis and compare phase arrivals across the network. The most important result of our work is that the blast generated clear, high-amplitude P waves with vertical dominance and energy concentrated between 2 and 4 Hz. If you want to find out more, please come over for a chat in front of our poster at board number 3. Thank you.
So I would like to thank all of the presenters there for the two topics, P2.2 and P3.5. On behalf of the SNT team, thank you so much, guys. And for those who are interested for the follow-up on that, because you have to support also those who are working on those posters, their work, please visit the poster session there, raise your questions, because there are a lot of things very interesting there, but it was an overview. For the details, join them, ask them, raise your questions. Thank you so much. Big applause to those who present here.